This video is having a look at finding the equation of a straight line and then also sketching that straight line. So we're sort of combining two slightly separate topics into one because they're very connected. So we want to be able to, when we're given 2 points, find the equation of that line because that will help us maybe make predictions or find other points on it. And we want to be able to represent those graphically, which is going to help us in later maths being able to sketch things. So we want to be able to find the equation of the line given 2 points or 1 point and a gradient. One of those points could be the intercept, it might not, we'll see. State the equation of vertical and horizontal lines, because those are special cases. And then find 2 points on a given line. So when you're given the equation, find 2 points and use those points to sketch that line. The most common form of a linear equation is something called gradient intercept form. So that's exactly what it sounds like, that we've got y equals, so y and x are just saying that it's a relationship between our y-axis and our x-axis on our Cartesian plane. So y and x aren't actually going to be numbers most of the time. They're literally going to be y and x. M is representing our gradient. As we know from when we find the gradient, we label it m. And C is representing our y-intercept. So that is the point that the line crosses the y-axis. So in this case, that would be our y-intercept right there. So if a question like this one says, state the gradient and y-axis intercept, so y-intercept of a line, if it's in your gradient intercept form and you've already got m and c, you can literally just say gradient is this number, y-intercept is this number. In this case, where we've got 3y plus 6x minus 9, we need to rearrange it into the correct form. So we want to get it to y equals mx plus c. So I would take 6x away from both sides. So we'd have 3y equals 9 minus 6x. And then we're going to divide both sides by 3 to get y by itself. So you'd have 9 minus 6x over 3. And we can simplify that to 3 minus 2x. To make it easier for ourselves, let's just flip that round so it's actually y equals mx plus c. So we've got negative 2x plus 3. So gradient equals negative 2. Y-intercept equals 3. Another common form is something called point gradient form. And as it might sound, this is useful when, rather than being given 2 points or the equation of the line, if you're given 1 point and the gradient, then it's going to be easy to find the equation of the line from those things. So in this case, y1, x1 are going to be the coordinates of that point. X and y stay the same, and m is still our gradient. So here we've got a line passing through -1, 3, so that's going to be x1 and y1, and a gradient m of 4. So we would write that out as y minus 3 equals 4 times x minus -1, so plus 1. However, we aren't actually ever going to leave a question in point gradient form. We always want to take it back to that slope-intercept form, which is often known as the standard form of a linear equation. So to do that, we just have to rearrange this equation. So first we'll expand the brackets. 4x plus 4, and then we're going to add 3 to both sides. So we get y equals 4x plus 7. So in this case, our gradient is 4, which we knew, and our y-intercept is going to be 7. If you wanted to do that a different way without using the point gradient form, you just wanted to look at your points and your gradient and know that they have to end up in our slope-intercept form, you can actually do that. So an alternate method might be to write y equals, we know the gradient is 4, so mx plus c. We don't know what c is. But because our point here is representing x and y somewhere, we can use that as x and y in this equation. So you would end up with 3 equals 4 times -1 plus c. So 3 equals -4 plus c. Add the 4 to both sides, 7 equals C. We've then solved for C, and you can put that right back into the equation like that. So you can see you end up with the right answer either way, just depends which one you prefer. If you've got 2 points, like you do here, rather than 1 point and a gradient, easiest thing to do, because I like that point gradient form, I think that's an easier method. So first off, we would find the gradient. So we'd go m equals, remember it's y2 minus y1, so 2 minus -2 over x2 minus x1. That's going to give us 4 over 2, which is 2. We can then just sub that using one of our points into our point gradient form. So we could go y minus, I'm going to use that second point because they're both positives. That's easier to think about. So y minus y1 equals 2 times x minus 3. So y minus 2 equals 2x minus 6, and y equals 2x minus 4. Remember we said that horizontal and vertical lines are a special case. So in the terms of their gradient, a horizontal line has a gradient of 0, and its equation is just going to be the value of that y-intercept, because if you think of y equals mx plus c, but m is 0, 0 times x is 0, so you just get y equals c. In terms of a vertical line, your gradient is undefined. And we're effectively going to do exactly what we've got for our horizontal line, but instead of y, we've got x, because we're literally just saying that at all times, that line has an x value of 3. So whatever the x-intercept is for that line, that's what you're going to have, your x equals that value. Finally, when we're sketching a line, you effectively just need 2 points, because if you're going to join 2 points up, they're going to make a straight line. So as long as you have 2 points that lie on a line, then you can sketch that line. To do that, the easiest thing is to find the intercepts. Now, if we think about where those intercepts exist, if you think about your axis, the y-axis exists at x equals 0, and the x-axis exists at y equals 0. So that's what we use. We're going to substitute those numbers in to find out where our line is at that value. So firstly, let's find our y-intercept. So x equals 0 at our y-intercept. So we're going to substitute x equals 0 into our equation. It doesn't even have to be in our standard gradient intercept form. You can just leave it exactly how it is. So we would have 2 times 0 plus 4y equals 10. That gives us just 4y equals 10. So then y equals 10 on 4, which is 5 on 2. So we would say y equals about 2.5. So let's go 1, 2.5. I'm going to put that dot right there. So that's our y-intercept. And then our x-intercept is going to be when y equals 0. So exactly the same process. But now we're substituting y for 0, so 2x plus 4y equals 10. That gives us just 2x equals 10. X is going to equal 5. So let's say we've got sort of 1, 2, 3, 4, 5. And when you're sketching, it doesn't have to be exact. The neater you can get it, the better, but it doesn't have to be absolutely perfect. So let's sketch a line that's going to go through both these points roughly. Oh, if OneNote will let me do that. There we go, close enough. So it's good practice. You've drawn your line, you would use a ruler. It's a good idea to then write the equation of that line next to it, because when we come to more complicated graphs with multiple lines, helps you keep track of which one is which. If you do want to use other points on the line to sketch it, that's absolutely fine. You don't have to find the intercepts. You could use x equals 1 and y equals 1. As long as you've got 2 points on that line, it really doesn't matter what the points are. As long as you've got 2, they're accurate, they both lie on the line, you'll be able to sketch it. So going back to our success criteria, we can find the equation of the line with 2 points, find it with 1 point and a gradient. We know that vertical and horizontal lines have those special equations and can use that. And we can find 2 points on a line and use that to sketch. Good luck.